Hi everyone. I have been thinking of making a video on biochemistry flags in biochemistry. So very basic. Sometimes on the biochemistry analyzers you have less than the repeat limits, like sodium 119. I think the normal range of sodium is 125 to 155 millimolar. But below 119 or at 119, the biochemistry analyzer will schedule this through a Java or C++ program for a repeat. So that's a less than repeat limit. And vice versa for any sodium over 150. The programming language or repeat limits are set on the analyzer to repeat a sodium of sodium or a potassium greater than 5 millimoles, or a sodium 150. Next, we have other flags. Greater than, or I'll start off with, I think, less than technical limit. So this is almost equivalent to less than test. So for example, like a PSA of 0.03, the assay does not detect that very accurately. So some laboratories give, like, let's say HbA1c less than 20. So you have an assay limit and you're going to report that in your lab less than 20. I think HbA1c millimoles per liter. Right? And the same goes with the greater than test. So above a certain limit, like LDH, occurs in tissue damage, maybe in with the Lights criteria, there is an albumin ratio. I don't remember, is it LDH with albumin ratio? Plurals and Lights criteria. So define exudate or internal transidate. So internal cell means transidate, external cell Lights criteria. So greater than test, you might have, I think it's 1000 for LDH. But there can also be an extended upper technical limit. So extended upper technical limit is almost the same as greater than test, greater than the amount the assay can quantify. So therefore you need a dilution factor. You might need to make, for an extended upper technical limit, you're going to need a higher dilution, just because the assay has reached a bigger dilution than expected for an automatic dilution. Sometimes you can have a smaller automated set dilution. Once you reach another limit, you have to go next, do a manual dilution. So basically we have greater than technical limits and less than technical limits. And on analyzers, the repeat limits. The Roche Cobos analyzer has a help icon near the stop button. So not this one with the arrow, because that doesn't take you anywhere. That just makes the arrow kind of freeze. There's a help screen. There's a help button, and it gives some definitions of the meanings of the biochemistry flags, such as check sample, that's a CITM middleware flag. Check sample is a CITM middleware flag, which is due to a short sample, like a sample S, low volume or debris in the sample, which means removing this debris or pouring in that sample into a hanging cup or false bottom tube to get that sample repeated. So less than test or a less than technical limit. To recap, trace quantity of biochemistry analyte greater than test, greater than quantity of analyte. So these are just the biochemistry flags. I also wanted to cover as well that for the E module assays, like beta HCG troponin, I've had a case in biochemistry where I've encountered procalcitonin did not have a linear range like this. What's the linearity factor of m equals 1? The slope. This is the slope. How it's shaped. The 1. mx plus c. So procalcitonin is a sepsis assay. Today, the calibrator, which gives the factory default to the assay, sort of a linear curve like this, which could be 0.95, 0.98, 1, and then you have to re-QC the assay. Every time you calibrate something, you have to re-QC it, and you have to rerun patient samples according to Westgard rules. If you re-QC, it's okay. Due to a poor IQC, you re-QC. Okay to release patient samples off when there's a poor QC, but it comes back within 2 SD. There's different types of rules. Like 1. So let's say you have 3 levels you run on the QC. There's just one level that's out on 2 SD. Let's say level 1, but you're measuring the high ranges for patient samples. Level 2 and 3 are okay on the rerun. However, the low level is off. The high level of QC is fine, along with the middle level. Like, let's say a high bilirubin. We're measuring a T billy, total bilirubin. This shows that the QC rerun is okay just because 1 point is over 2 standard deviations. While the other 2, but within 3 SD, but the other 2 are okay. Technically, that's okay when you're measuring a very high bilirubin level, and vice versa. A low trace billy, your level 1 has run back in within 2 SD. Level 2, okay. Level 3, if it's out, just 2 SD, no more than 3 SD. That's okay. But if 2 levels are greater than 2 SD on a rerun, you have to recalibrate your biochemistry method. You have to recalibrate it. Then after calibration, test the calibration, then rerun patient samples. Now, for calibration to pass on the E module, it has to be, I think, 0.8 to 1.05. I think if it's 1.05, it's kind of like this. Or 1.1 is probably going to be okay. Your QC will show you how the recoveries are on your linear curve of that calibration. So this is my small lecture on biochemistry flags. I hope this video helps. I really wanted to get across the explanations of biochemistry flags, as I have never found on YouTube anywhere any lectures on biochemistry flags. So 0.8 to 1.05 is for lot calibrations rather than current RPACs, simply because of the lot calibration, you do it once within 24 hours, and the entire batch of reagents, are then calibrated and good to go for that month. So this is just a rundown of Roche Cobos biochemistry flags and methods.